Hello everyone. For today's video, we're going to talk about introduction to graphing polynomial functions, but to be specific, we're going to have end behavior of the graphs of polynomial function. So we have here our first activity. I'd like you to indicate or determine what is asked in the given problem. So we have here first polynomial function. I'd like you to identify the degree, if it is odd number or even number. Identify if the leading coefficient is considered positive or negative. And lastly, identify the maximum number of turning points. Okay, so first for our degree, here we have x raised to the fourth power minus 5x squared plus 4. Our highest exponent used in the polynomial function is 4. Therefore, we can say that 4 is an even number. Okay, next. And for our leading coefficient, so as you can see here in our leading term, x raised to the fourth power, therefore it's 1 and it is positive. And lastly, number of turning points. So again, what will be our formula to find the maximum number of turning points? So based on the definition, it is at most n minus 1. So therefore, n refers to the degree of the given polynomial function. So based here in our answer a while ago, for degree it's 4. So 4 minus 1 it's 3. Therefore, we can say that the number of turning points would be at most 3 or maximum of 3 turning points. Therefore, we may have 3, 2, or 1 turning points. So that's it. Okay, next example. So, given this polynomial function, let us identify the degree, the leading coefficient, and turning points again. So, for the degree, so what would be the highest exponents used in the given polynomial function? As you can see, we do have here 1, 3, 4, 5, 6. So, the highest exponent used is 6. So, here, so 6, is it odd number or even number? So 6 is an even number. Okay, next. How about our leading coefficient? So of course, to find out the leading coefficient, you just simply look at the leading term. So it is already arranged in decreasing order, so it is easier for us to identify which one is our leading term, and that is our first term. So negative 5x raised to the 6th power, so our leading coefficient is negative 5, and of course, as you can see, it is negative. Okay, and lastly, for number of turning points, so using again the formula n minus 1, or the degree minus 1. So since our degree is 6, so 6 minus 1 it's 5. Therefore, we may have 5 turning points, or we may have 4, 3, 2, or 1 turning point. Okay. So, another example. So, given this polynomial function, identify again the degree, if it's odd or even, leading coefficient, if it's positive or negative, and the maximum number of turning points. So, here, our degree, since it is already arranged in decreasing order, therefore, look at the first term, and that is x raised to the 5th power, and we do have here 5 as the degree, and we all know 5 is an odd number. Okay, and for our leading coefficient, since our first term is x raised to the 5th power, therefore we can say that our leading coefficient is 1, and as you can see, it's positive. Okay, and for the maximum number of turning points, again, so we have n minus 1, so our formula, so degree minus 1, so 5 minus 1, we may have 4 turning points, or else we may have 3 turning points, 2 and or 1. So again, it's at most 4, or also we can say that it is less than 5. Okay, so what are those numbers less than 5? So we may have 4, 3, 2, and 1. It has the same concept behind. Okay. Okay, so for now, we're going to determine already the end behavior of the given polynomial by what we call leading coefficient test. So what is behind leading coefficient test? So for us to apply this leading coefficient test, you just simply identify the leading coefficient if it's positive or negative, at the same time the degree of the given polynomial equation if it's odd or even, just like what we did in our previous activity. So let us have our first polynomial function. Now, first and foremost, so for you to be able to identify easily and so that you will not be confused, better if you start with looking at the degree of the given polynomial function. Since it's an even, the degree is an even number, which is 4, so we can now say that both arrows will be going either upward or downward. So that's it. Both arrows will be rising or else falling. But what would help you decide if it's really going upward or really going downward? Now, it's the leading coefficient. You look at the leading coefficient. Is it positive or negative? Base here in our polynomial function, it's positive. Therefore, I'll give you this clue. What part of the Cartesian plane indicates positive side? Is it going upward or going downward? It's going upward, right? So therefore, that would give you the clue that if the degree is even and the leading coefficient is positive, therefore the arrows will be going upward, or you can say that it rises to the left and to the right, or both rises or else both arrows will be going upward. So in other books, there's a lot of phrases that would tell you the end behavior of the polynomial, but what matters most is that they do have the same idea behind. So you may use the word rise or upward and then fall for downward. Okay, next example. So we have here p of x equals negative 2x raised to the 6th power minus 3x raised to the 5th power plus 2x raised to the 4th power plus x cubed plus 6x minus 1. So same process. First and foremost, you look at the degree. It's an even number once more. Therefore, you can say that both arrows will be going in the same direction. But you decide, is it going upward again or going downward? So here, as you can see, the leading coefficient is negative. Therefore, what part of the Cartesian plane would indicate negative side? Is it going upward or going downward? So it's going downward. So you may indicate that the end behavior of the given polynomial will be both arrows will be going downward. So, or you may rephrase it into both falls to the left and to the right. Okay, so another. P of x is equal to, so given this polynomial function, so I will just repeat the process. You look at the degree. This time, as you can see, it's an odd number. So if it is an odd number, therefore, we can conclude that the direction of the arrows of the graph of this given polynomial function will be going two different directions. One would be rising and one would be falling at the other side. So, in this case, what would help you as well to identify which arrow will be going upward or will be going downward. So here's the leading coefficient again. You look at the leading coefficient, it's negative. And this time, my clue is which part of the Cartesian plane would indicate negative side. Looking at the x-axis. So which part? Is it at the left side of the Cartesian plane or at the right side of the Cartesian plane? So obviously, the negative side of the Cartesian plane is at the left side, right? So therefore, the emphasis in the graph of this given polynomial function, it will be rises to the left at the negative side of the Cartesian plane and falls to the right side of the Cartesian plane. So that's it, the end behavior of our third polynomial function. Okay, so thank you so much for watching this video. I do hope you learn about determining the end behavior of the graphs of polynomial function using the leading coefficient test. Okay, so don't forget to subscribe now so that you will be notified of the next video lessons. Thank you.